In the realm of industrial manufacturing, especially within the automotive sector, every moment of downtime can equate to significant financial loss. An unexpected halt in machinery, such as a press or conveyor belt, not only disrupts the production flow but can also stall the entire supply chain. This is where the importance of predictive maintenance comes into play. By leveraging advanced technologies, manufacturers can predict and prevent interruptions, ensuring a seamless production process. Imagine a scenario where your production line operates without unexpected halts, maintaining a steady flow and maximizing output. This is the promise of integrating cloud-based artificial intelligence with your industrial automation systems. But there's more to this than just avoiding disruptions. It's about optimizing every aspect of your manufacturing process to achieve peak efficiency and reliability. The AI software we're discussing operates by continuously collecting and analyzing data from various sensors across the manufacturing line. Imagine each sensor as a sentinel, vigilantly monitoring parameters like temperature, vibration, and operational cycles. The AI algorithms then process this data, searching for patterns and anomalies that could indicate potential equipment malfunctions. For instance, if a motor's vibration levels start to deviate from the norm, the AI flags this as a potential issue. This proactive detection allows maintenance teams to intervene before a critical failure occurs, minimizing downtime and optimizing resource use. And here's why that matters. By addressing problems preemptively, manufacturers can avoid the costly disruptions that come with unexpected machinery failures. And here's why that matters. The heart of industrial automation lies in the seamless integration of programmable logic controllers, or PLCs, with advanced engineering frameworks like the TIA portal. PLCs are the unsung heroes, collecting real-time data from sensors and machines. This data is crucial for the AI algorithms to analyze and predict potential issues. The TIA portal, on the other hand, is your command center. It's where you program and configure these PLCs, ensuring that every aspect of your automation system is fine-tuned for peak performance. When you integrate AI-driven predictive maintenance with PLCs in the TIA portal, you're not just reducing downtime, you're transforming your entire manufacturing process. This integration allows for a dynamic response to the machinery's condition, suggesting maintenance actions before a failure occurs. Imagine your production line is a well-oiled machine, where every component is monitored and maintained proactively. This is the power of integrating AI with PLCs in the TIA portal. To begin setting up predictive maintenance, first, ensure your PLCs are correctly configured to collect real-time data from sensors. Navigate to the TIA portal and open your project. Select the PLC you wish to configure. Under the Hardware tab, choose Devices and Networks. Locate your sensor devices and ensure they are correctly assigned to the appropriate data points. Next, configure the communication parameters. Set the baud rate to 19,200 for optimal data transmission. Enable cyclic data exchange to ensure continuous data flow. Now, move to the Tags section and create new tags for the sensor data. Name them logically, such as motor vibration and temperature sensor. Assign these tags to the corresponding data points. This initial configuration ensures your PLCs are ready to transmit data to the AI software for analysis. Remember, precise configuration here is crucial for accurate predictive maintenance. Now, let's dive into the execution phase and the underlying code logic that makes AI-driven predictive maintenance a reality. Imagine you're working with a PLC in the TIA portal. First, you'll need to configure the PLC to collect sensor data at regular intervals. Set the sampling rate to 100 milliseconds for high-frequency data acquisition. Next, establish a secure connection to your cloud-based AI software. Use a MQTT protocol for real-time data transmission. Ensure your firewall settings allow outbound connections on port 1883. On the AI side, implement a machine learning model, such as a random forest classifier, to analyze incoming data. Train the model using historical data from your machines. For deployment, containerize your AI application using Docker. This ensures consistency across different environments. Remember, the key parameter here is the threshold value for anomaly detection. Set this to 0.05 for sensitive equipment. This approach not only minimizes downtime but also optimizes resource use. By integrating AI with PLCs in the TIA portal, you create a resilient and efficient production environment. Understanding common pitfalls and debugging tips is crucial for maintaining an efficient predictive maintenance system. One frequent issue is data quality. Poor quality data can lead to inaccurate predictions. Ensure your sensors are calibrated correctly and data is clean. Another common problem is algorithm drift. Over time, machine learning models may become less accurate. Regularly retrain your models with fresh data to maintain accuracy. When debugging, start by checking the data logs. Look for anomalies or patterns that don't align with expected behavior. Use these insights to adjust your model parameters or clean your data. Remember, the key to successful predictive maintenance is continuous monitoring and adaptation. Stay vigilant and proactive in addressing these common issues to ensure your system remains effective.